Hello. Welcome to the 7th Technical Labs. We're going to be covering build automation systems, or build systems, naming it, and continuous integration, or continuous deployment. Again, naming is hard when it comes to these tools. We'll give it a few minutes for people to trickle in. Notes have been posted if anyone prefers to go through the notes or follow along with us. Yeah, let's get going. Okay, so a few things to begin with. So we're covering the topic. Basically, the real topic we're covering is meta programming, which is programming for your programming. So this is writing code to help you write code. Can be kind of mind-bending. And metaprogramming is an extremely broad topic. We're going to sort of divide it into 4 categories. The term metaprogramming, I think, is coined by the Missing Semester series run by MIT, which sort of inspired this series. And so yeah. So a lot of the time, right, if you're a computer scientist, you know computers have an amazing power to automate things and make things faster and to make repetitive tasks just disappear. That's like their whole thing. You may also be aware that when doing developing, you spend a lot of time doing repetitive things and menial tasks. Just like, okay, I need to test this, I need to build this, I need to just run this again. And for this reason, because, you know, it's annoying tasks for developers, and developers can write code. There's a lot of systems to automate these tasks. Okay, and so a lot of these tools are completely over the top for small projects. Like we're just going to be showing you some examples today, and all of the systems we're using are just completely over the top. You'll spend a lot more time setting them up than you would ever actually save using them. However, if you have a massive project, this very quickly gets flipped on its head. You know, with any sort of big open source project, or even just a bigger, just slightly bigger than we're going for, probably some of your courseworks are big enough for this, you would actually save a lot of time by using these sort of meta-programming, setting up these meta-programming tools. Okay, so we're going to loosely group these into 4 categories. However, a lot of tools span multiple categories or sort of don't fully encompass any category, and these categories have a lot of overlap, which is why we're sort of covering them in 2 sessions, and it's hard to talk about, and we'll get to why later. Okay, let's actually cover that first. Why is this topic so broad? So a lot of these tools, different languages and technologies bring their own set of tools. So like, for instance, Rust has a very comprehensive set of tooling behind it that is completely, different from something like the Java set of tooling. And then Python has its own set of tooling. And then you've got other systems that try and encompass all of these and try to be a universal system. And so there's just some competing tools and standards. Every language has their own, and then there's bigger ones. And if you want an example of this, look at Wikipedia's list of build automation tools. The link is in the notes. It is hilarious. It's like a few hundred elements long. And also see XKCD number 927, which is just a very good XKCD comic. Okay, so what categories are we going to go for? So we're going to go for the categories of build automation, continuous integration and deployment, dependency management, and unit testing. Don't worry about what these are at the moment, but we're going to cover 1 and 2 today, and then 3 and 4 next week. Cool. Yeah. All right, so let's get into build automation systems first. Okay, so what is a build automation system? Well, first, actually, let's talk about what I mean by build. Build is a very, very loose term. Note that I'm not saying compile. A lot of the time, building is compiling. You know, you have a big code base, you need to compile that down into bytecode or a binary. it down into HTML or something, that is compiling. But sometimes it's absolutely not compiling. For example, the example we're going to use, slightly a mouthful, is generating a PDF document from LaTeX code. That's sort of compiling, but you wouldn't really call that compiling normally. But we will still call that building. We're just going to use building as a very loose term for taking sort of source documents and making a final product. Cool. So what is build automation? So build automation is basically the process I just described. So a lot of projects, you have different technologies and different assets that are all sort of, all require different tools to compile in, for large projects. So for apps, this is very common with apps. You might have different languages, different libraries that all need to be compiled in sequence and then brought in or downloaded off the internet. It's like there can be a lot of jobs that need to be done in a sequence. And you could just run these steps one by one by one. LaTeX is a very good example of this. If you're doing like a bibliography in LaTeX, you need to run about 5 commands each time you want to build, and it can be a pain. I've just been doing a lot of LaTeX bibliographies. And if you want collaborators, so you could just post a list of commands that you need to run in order to build your project, and for small projects that would work. But for big projects where you want collaborators, this could either be very, very time consuming and just irritating, and could take, it could be a hurdle to collaborators joining the project, and it could just not really be feasible. Once this list of commands gets too long, it's just not possible. Or it may just take hours. Sometimes compiling a library can take absolutely hours. Okay, and so this is when we get onto build automation systems. So there are tons and tons of build automation systems. Which one's best depends on what technology you're using, the size of the project, etc. But regardless of that, most all of build automation systems run on a sort of data model of dependencies, targets, and rules. Okay, so a target is anything you can build. So we're going to switch to drawing here. So let's go for the example we have today. Okay, so what we have is we have a Python program. Okay, that takes a set of data points and generates a graph. Then we also have a data file with just a set of data points that we want to plot. And then we also have some LaTeX code. So LaTeX is a language for, a programming language for making documents. In this case, we're going to be making a PDF document. And so then so these are all dependencies. They're sort of base level dependencies because we've got them in file, right? We've just got the files. And then from these, we can generate targets. Okay, so here I think it's something like data plot.png. So PNG means this is an image. And this takes data.dat and plot.png. Okay, so this is a target here. I can say to the build system, I want to build this, and it knows it has to have plot.py and data.dat. It has to have these files. So these are this target's dependencies. So it depends on these. And then you can set up rules, and a rule dictates how we can make this from its dependencies. Okay? And then we also have paper.pdf. That is an F, believe it or not. So this is the final document we want to make, and this requires paper.text, so that's one of its dependencies, and this other target. So a target itself can be a dependency, because I want to put this plot into my paper. And what the build system will do is if I say I want to build this, it will sort of search up the tree until it finds all of the furthest up dependencies that are actually just files. And it will then construct all of the more inner dependencies, these sort of, what do I call it in the notes? Intermediate targets. So it will find all the transitive. It will find all the transitive dependencies and apply the rules to produce the intermediate targets. So these are the intermediate targets, and these are the transitive dependencies. They're sort of the concrete dependencies. Okay, so this is great. This can help us a lot. So here you can see how this will stop me having to render this image every time. If I just say, make this, it will do everything else we need. And we could have a set of different dependencies. So we had a load of papers that all relied on the same thing. We could have a load of dependencies that are sort of connected. But one of the main features of a build system is it will try and cut out all the steps it doesn't need. So for example, your file system will remember the last time these files were edited. And so if I make the document, and then edit paper.txt and make it again, it knows these haven't changed. And so this won't have changed. And so all it needs to do is recompile this. It won't bother going through this step here, which in this case won't matter because it'll be very quick. But on bigger projects, this can save you tons of time.
Python code could still be quite slow.
Oh yeah, absolutely. It could be. In this case, it's not. It's like a 4-line script. But in some cases, yeah, this could take like ages. Often what this will actually be, if you're doing like a code base, is this will be a library. So it could be like your internal library, and this will be the code bases for this library. And if you can build this library and then just have the binary and not have to build it any time, this can take minutes or like tens and tens of minutes. And if you want to build often, this can save you tons and tons of time.
I have a question.
Yes?
Would data.plot.png have a makefile for its creation, or would you have all this information stored in a final makefile?
You would have this all in one makefile. So one makefile would encompass all of that. We'll show that in a minute, actually. Okay, let's do it. So I have grabbed the code from the notes. I've downloaded them to my laptop so I can show you. But feel free to have a look if you would like. So let's answer Joe's question first. So here I'm going to use NVim, which is NeoVim. It's my editor of choice. It's not really important. And then Makefile, which is, so we're going to use Unix Make. It's a very old build automation system. It was made in Bell Labs back when Unix was made, long time ago. It's now old and crusty and it's got rough edges, but it still works for sort of moderately sized projects. Okay, so here we go. We look at this file. So each section of this, so you see there's like elements of this list. This is a make file. Each section is a rule. And so we've got the first line here, which, so you see we've said paper PDF. So like this specifies a target. So it says this target and its dependencies. Its dependencies are paper.txt and, I got it the wrong way around, plotdata.png. And then it specifies the command to make this, to make paper.pdf from its dependencies. Okay? So this first section is this here. Okay? And then this next line is this here. Okay? So this is saying to make plotdata.png, take data.dat and plot.py and run the Python code with some flags. And it will, that's how we make dataplot.png. Does that answer your question? Okay, cool. Okay, so this is how a makefile looks. Normally they'll be much more complicated and you can add like flags and things. You can add some really cool stuff in makefiles. So yeah, we're not going to show that now. but you can do a lot of really complicated stuff with makefiles. I recommend, if you want to get more into them, read the manual, the GNU manual. Okay. Also, I should just list the files I've got here, so you can see the files I've got. Okay, and then I'm just going to quickly show you all of them. I'm just going to quickly print out the contents of data.dat. You can see it's just a bunch of points. It's very boring. There is paper.txt. You can see it's a really, really simple document. We're just going to start a document, include a package, and it's just going to be an image, this one image. Just very quickly, this example is taken from Missing Semester. It's really hard to come up with examples, good examples for build automation software, so I used theirs, so credit to them. And here's the plot program. It's just using external libraries to plot this thing. You can find the code for this if you want to play around with it yourself on the notes. Okay, so that's all the code. And now we can do something like make, and then we can specify what we want to make. So let's go straight for make paper.pdf. Okay. So first you can see what it did is it first ran the Python program, because it had to make the inner dependencies, the intermediate targets. Okay, so it first did this, because we didn't have one yet. And then it ran this step. This latex is really, really verbose, and so you can see all the stuff it's done. And if we open up the paper, you will see, look, it's certainly a plot on a document. Can give it that. Okay, and if I try and make paper.pdf again, it knows that nothing has changed, and so it just tells me nothing's changed. If I So what I'm going to do is add some data, another data point into the data file, and then run it again. What you can see is it's detected that something's changed, and it's going to again run the Python thing. So this has changed, so this has changed, which means this has changed, which means this has changed. So it's going to run it all again. Now, as you can see, our document's now changed. Cool. And if what I can do here is pretty easy. If you give me a second, I'll just up the font size. So I've just added a title to this LaTeX document. We're not going to go into how LaTeX works. And then I'm going to make the document again. And you can see what it did this time is it didn't run the make the graph function, because we only needed this, so it didn't bother running that. And so now we've got a title. Lovely. Let me just up my font size. Better? Lovely. Okay, so that is a very brief description of makefiles. So, do I have anything else to cover for this? Cool. Yeah. And again, you can specify a bunch of rules. So say you had a bunch of data documents, and you just wanted to be able to, if you look at the Missing Semester example, they do this. If you wanted to be able to just take I wanted to be able to say, data, if I wanted to just be able to say, you could do something like I think it's like %.plot. Oh no, actually, sorry. At symbol plot, then this will, you could say I want data.plot, and it, data/plot, sorry, and it will fill in this wildcard here. And then I could, instead of doing this, do %1, and this will fill in here. And so I could say I want data plot, and it will look for data.dat and build that all for me. And then I could also have data 5.dat or data about Joe's hair.dat, etc., etc., etc. You know, daily floofiness and things. Okay, any questions about makefiles before we move on? I'm kind of hoping that this is, you can see how this will be useful. I don't suppose it will be massively useful for any of your courseworks, really, but it is massively useful in industry, where, like, where these sort of steps can take absolutely ages. Compiling something like a application, if you had to compile everything from its basics, I compiled, so this is my terminal emulator, Alacrity, and I did build it from binary because I needed a new version, and it took about 20 minutes. But then when I ran it the second time, because everything was already built and I just changed a small thing, it took a few seconds, right? And so for a project like this, it's much more useful, and hopefully you guys may actually go on to work on big projects like this if you want to. Cool. Any questions? Lovely. All right. So now we're going to move on to continuous integration. Okie dokie. So, build automation is the automating of the step where you are going from your code base to building. It's automation around that. And there's a lot of stuff around there, and it's very useful. But there's that's just one step in the development process you might want to automate. Another thing people often want to automate is whenever you make a change to a project. So say me and Joe are running on a project, and we've made some unit tests, which may be the subject of next week. Then whenever either of us make a change to a project, we probably want to run those unit tests. Whenever we push to our Git repo, we might want to run those unit tests to make sure that our Git repo, that the code still works, still compiles. We have some sort of tests for the basic functionality to make sure that all still works. This is really, really common in industry. Any sort of important project will have some sort of unit tests. There's also other stuff you might want to do when you push to a Git repo. For instance, the example we're going to go through now, I have a website. My website the code is on a Git repo. It used to be that whenever I would push to that, I would make a change to the website, then I'd push to the Git repo, then I'd log on to my server with SSH, and I'd pull the Git repo, and I'd build the website from my code, then I'd move it over. And that's fine. It takes a few minutes, but it's quite annoying. You know, it's error prone, it can go wrong, and it made me not want to update my website. I knew my website was old, I knew it had incorrect information on it, and I didn't want to update it because it would have been a pain just to do these steps. And me and Joe have worked on projects where we have not updated things because it would have been a pain to go into the server and change things over, and it's just too much of a hassle. And that's really, really bad. You want to encourage updates, you want to encourage fixing things, everything like that. And so that's where continuous deployment comes in. So continuous deployment is a subset of continuous integration, mainly used on servers, though it's used in a lot of other places as well, actually. That whenever you push to a shared repository, it doesn't have to be a repository, you can use a different version control system, whatever, then it will build that code and deploy it somewhere. So in my case, it deploys it to my server to be served up for to my people coming to my website. So we're going to have a look at my repository. Okay, so this is my local. Cool. This is my Git repo on my local computer. It's my local implementation of it, and this has so this uses a continuous integration system called Github Actions, which is GitHub's continuous integration toolset. And so if I push from this repo, it will automatically. So a quick explanation of what Jekyll is. So Jekyll takes. So here you can see Markdown files. It takes Markdown, and which is just a very nice, sort of a nice looking syntax. It isn't that nice here, but that's for other reasons. So you can see, like, this is how you make something a title, is you give it a little underline. It's rather nice. It takes Markdown and compiles that to HTML and makes a website out of it. It's a really nice little tool. It's how we make the technical labs notes, so if you want to go have a look at them. GitHub has a thing called Github Pages, which is great. I love it. That's how we run the technical lab site. It's not how my website is run, but that's all powered by Jekyll. Okay, so I have a continuous integration script. So it's in .github.workflows. So here you can see it's main.yml. Okay, so this is my continuous integration workflow. So I'm just going to very quickly go through this. So I'm just trying to give you a flavor of what continuous integration deployment can do. I'm not doing a tutorial on GitHub Actions. If you want that, GitHub's docs are great, and they will teach you more of how to do it. So here I'm saying whenever I push or merge into main, or I can just run it manually, do these things. So GitHub Actions is really, really cool. I'm just going to give a quick explanation of what GitHub Actions does. It makes you, so on GitHub servers, they make a small virtual machine, so in this case, an Ubuntu machine, and you can just run some commands on there, and then it will destroy the virtual machine. So it just gives you a little bit of time to run some commands on their servers. So it makes a virtual machine for me. I check out my repository into this virtual machine. I then use, I run Jekyll build, which builds the website, and then I use SCP, which is secure copy, to copy it over to to my server. And I'm using Github Secrets so that you guys can't see my passwords. Okay, so that's what this is doing. And if we, oh dear, close all that. If I go to my website, here we go, you will see, so there's this little check mark, that's GitHub Actions. So you can see whenever I push, so the last time I pushed was 3 days ago, it runs the continuous deployment action. So here it had to set everything up, it built the website, then so here it installed everything and built it, then it copied it to the server, etc., etc. Then it destroyed the little virtual machine. And it will just update my website whenever I push to the server. It's great. One of the other things that's really useful about GitHub Actions is you can see, if I go back into here, you can see a lot of these. I haven't actually written anything. So like checkout, for instance. I haven't written anything here. I haven't written any code or anything. GitHub Actions has a marketplace where you can use other people's GitHub Actions. So here I'm using GitHub's checkout. So it runs their code. Someone's built a Jekyll action for building, and I just use theirs. Same thing in the SCP, I just had to give it some parameters. It is really cool. Again, this may seem boring, but for a lot of projects we've done, this either has or would have saved us tons and tons and tons of time. Do you have a question? Okay, cool. Sorry. Oh, okay, I see. And continual integration is something that will actually be useful for some of your courseworks, or could be if you wanted to. So for instance, I'm going to talk about my DSA coursework. So that's data structure and algorithms. I believe most computer scientists will take it next year. And one of the courseworks they get us to do, we had to implement a sorting algorithm. Just a cool data structure and algorithm thing, sort of, fairly standard. And so they got us to implement 4 different algorithms. And so what I did is I set up a GitHub action. So I stored it on Git, because of course I did GitHub, because of course I did. And I set up a little continuous integration script to, it's a private repo, so don't go look, I think. Oh, it is public. Whoopsie. Okay, unless any of you were very quick, that is now private. Whoopsie, whoops. Sorry about that. So I have an action on there, and it will run my code with a test suite I made, and tests each of my sorting algorithms works, and tests other things work. And this, took some time. It took me sort of half an hour to set up, but now I accurately know that if a version of my coursework works or not. I can just test it, and I know this one works, this one doesn't. And when you're submitting coursework, especially if you're close to the deadline, you can spend a lot of time testing and having problems with versions that do work and don't work. It causes you loads and loads of problems. For me, it's just really nice to know for each of my versions, this does work, this doesn't work. I broke something here, I fixed it here, I implemented sorting algorithm 1, 2, 3, 4, etc., etc. It's really nice, I really like it. Okay, let's go home. Cool. Let me see if I have anything else in my notes I want to cover. That's the GitHub. Cool. Cool. Yeah, something else on GitHub Secrets. As I showed you, I'm using GitHub Secrets so that you can't see my passcodes and stuff and my SSH key for my using SSH. I just want to spend some time to emphasize how important this is. So many big companies and just big open source projects have had massive disasters because people have gone through their Git history and found old keys or passwords lying around in there that they didn't think about, and managed to log in and change stuff and take massive projects down, delete massive amounts of data. It's really, really can be a disaster. Yeah. Also, another point about continuous deployment specifically. So you notice I had continuous deployment to only update when I'm on the main branch. So this is, if you watch the Git lectures, we talked about how one methodology a lot of people use, including myself, is that anything on the main branch works. So whenever I do work on my website, I will go onto a branch, update it, running it locally on my machine until I'm happy with it, and it runs, and then I'll merge it into the main branch when I know it works. And so the main branch is just the working versions. But you probably won't actually see that if you look at my GitHub, because I don't upload the other branches. They're just local branches. But anyway, hopefully you get that. Cool. There's a massive amount of tasks you can automate with GitHub Actions, and there's a vast array of similar continuous integration tools. I know loads of people really like, what's the famous butler's name beginning with a J? Famous butler beginning with J? Jarvis. There's a tool called Jarvis that is very, very popular and people really like. GitLab has something called GitLab Pipes, which is incredibly popular as well. So anything like that will do the same things and are all really cool. Okay. Jenkins. Jarvis is from Marvel. Jenkins. Okay. So just talk. Thank you, Sam Briggs, apparently. If anyone has any questions you want to ask, please send them in. Thanks for this section. So example was taken from Missing Semester, and they sort of inspired this whole series. Other research was done from the GitHub docs. So GitHub have just some rather nice documentation for all of this stuff. And the GNU Make manual. GNU just makes some the GNU project makes some really incredible manuals for tools, for like open source tools. Couldn't be more grateful for them. Joe edited the notes. Our friend Soren had some additions and some corrections for us. Yeah. Lovely. Any questions? So next week we are going to cover dependency management and unit testing. So by dependency management, I want to touch more on plugin systems. So something like pip for Python, or cargo for Rust, or I can't remember the one of the name for Java, but there's one for Java. Git has its own sort of dependency management tools that are just coming in. And dependency management is very important, and certainly I know, sorry? Maven. Yeah, sort of Maven. Sort of. That's more of a build automation system. Sorry. I know Joe and I have spent a lot of time very confused by plugin systems and their weird quirks, but they all work really similarly and that'll be useful. And then we're going to cover, what's the other one we're covering? Unit testing. Unit testing is a pain. No one likes unit testing, but once you've set it up, it is incredibly useful. Like I said, for my coursework, and it's an incredibly useful skill to have. A lot of employers really look for people who have unit testing skills because it just really elevates your level as a computer scientist. You know, it's like a good computer scientist doesn't just write code with no errors. No one can write code with no errors. A good computer scientist has things to stop his errors getting into their errors getting into a code base, right? Cool. And that is what unit testing is. Unit testing is an incredible tool, and it's incredibly important. Okay. All right. Thanks for coming. See you next week. Thanks to Joe for running tech.